Assalamu alaikum guys, welcome to my channel Electronic Devices Analysis. So guys, our today's topic is bipolar junction transistors, also known as BJTs. Our today's topic is structure, working and formulas of bipolar junction transistors. So before I start our lecture, please subscribe our channel and press on bell icon for the notifications of videos which I will upload in future. First of all, we see that the working of an NPN transistor. An NPN transistor is the type of bipolar junction transistors. NPN transistor working is similarly opposite to the PNP transistor. So we now only study NPN transistor working, which is exactly equals to the working of PNP transistor. So let's start. So guys, as we see that a transistor has three terminals: collector, base and emitter terminal. This is one is collector terminal, this one is base terminal and this one is an emitter terminal. In previous lecture we will see that an emitter terminal or an emitter area will be heavily doped. Similarly, base area will be lightly doped and collector area will be moderately doped. So doping means the impurity adding in that area. So medium number of impurities added in collector, a small number of impurities added in base terminal, or heavy impurities are added in emitter terminal. This one is NPN transistor, so this one is negative, this one is positive and this one is negative. A transistor will work efficiently if its base emitter terminal is forward biased and collector base terminal is reverse biased. So guys, if this is positive and base emitter terminal will be forward biased, then there is a battery which is positive point over here and negative points over there, negative to positive. So it will becomes a forward bias condition, and collector base terminal is reverse biased. So the collector is negative, so there is positive battery terminal is over here and negative terminal battery is connected with base, so it will be reverse biased. Then if this will be a forward bias condition, then it will work like a diode. Base emitter junction is working like a diode and collector base terminal is similarly like an open circuit. So the highly amount of current will flow in that transistor, and this is all the working of a transistor. The thickness of the base terminal is so small, so there is a small current is produced by the base, or collector current will be similarly equals to the emitter current. So IC will be approximately equals to IE, and IE we can say that IC plus IB, base current plus collector current, is equals to the emitter current. Emitter current is the addition of both collector current and emitter base current. If base current will be ignored due to a small light area, so it will be ignored and small current will be ignored, so collector current will be approximately equals to the emitter current. So now from our this understanding we will make a circuit of a transistor, NPN transistor. This is a simple circuit of a transistor. In this circuit we will see that the emitter terminal is grounded, so it is called common emitter configuration. We will start configurations from our next lectures. So guys, we will derive some formulas from this circuit. In this circuit we will see that there is the two resistance present in that circuit, the base resistance and the collector resistance, which is on the collector side. This will call RC and this will call RB, and this is a VBB double subscript, it is called a battery. When a double subscript are present, then you will know that it will be a battery. Here as we see that there is a diode what? This will be a positive side connected with positive, and negative side will be connected with the negative terminal of the battery in NPN transistor. So it will be a forward bias diode, and it will be fixed at 0.7 volts. So now we'll derive some formulas. As we know that, first of all, we see the voltage of collector voltage. Collector voltage is what? Vc will be equals to the voltage the battery will supply voltage to the resistance. The drop will be resistance will be subtract from this battery is called collector voltage. Vcc minus Ic into Rc. This is the collector voltage, and this will, this is emitter terminal and this will be a base terminal. So VBE is always fixed at 0.7 volts in silicon, otherwise 0.3 volts in case of germanium. As we see that the emitter terminal is grounded, so VE is 0. So VBE what? VBE is equals to VB minus VE. VCE will be equals to VC minus VE. So double subscript will be shown over this method. So if VE will be equals to 0, so VB is equals to 0.7 volts. And if you want to find VCE, then collector voltage is what? If VC, if you know, then emitter voltage will be 0 volts. So it will be a VC volts. Collector voltage will be shown. And if you want to find the base voltage VB will be equals to VBB minus 0.7, and 0, this voltage battery will be minus from this voltage minus 0.7 or VBE over RB. Then it will be a base voltage formula. And there are some other formulas. Beta will be equals to IC over IB. The beta is also called an amplification factor, where alpha will be equals to IC over IE. Beta is approximately greater than 50 or 60, where alpha is always less than 1. So guys, that's all. These are all formulas we will use in our transistor circuits. So guys, that's all for today. If you like our video, subscribe our channel and press on bell icon. That's all for today. Thanks.